Hello everyone, so welcome to my new video. In this video we shall be beginning with the series of the three-dimensional geometry and then moving on to solve the high level questions. So I'm pretty excited for it because I'm making mathematics video after a long time. So let me begin with it. So let me first of all tell you the basics that I want you people to know before beginning this chapter. The dot product A dot B is equal to modulus of A into modulus of B into cos theta, where theta is the angle between the vectors. And A cross B is equal to mod A mod B into sine theta neta cap. These two are known to you because you have already solved the chapter vectors. Now the next point which I want you people to know is that any vector A B can be written as OB vector minus OA vector. Now how is this so? Because let me take any coordinate axis. This is the x-axis, this is the y-axis. This is the origin O, this is the point A here, so this is the point B here. Now we need to find AB. So this vector, first of all let us see that what is this vector. This vector will be OA vector and this vector will be equal to OB vector. Okay, so I hope the point is clear. This is the OA vector we are taking towards the point along which it is pointed. So now let us find AB vector. So from A to B. So AB vector is from A to B. So using the vector laws of triangular addition, that is OA vector plus AB vector. See, OA vector along this direction and AB vector along this direction will be equal to OB vector. This is the triangular law of vector addition. So from here AB vector will be equal to OB vector minus OA vector. So this is the point which I want you people to know. So only these 3 points are important for beginning the chapter. So let us begin with it. So if we have 4 points A, B, C, D in space, then how can we decide that which type of quadrilateral is formed? I want you people to solve it by vectors and not using the elementary method of Pythagoras theorem, etc. So what is the first thing which you must need to do is that we have 4 points A, B, C and D. It can be anywhere in space. What I want you people to do is that first of all find the 4 vectors that can be generated from here. So those will be AB vector, BC vector, CD vector and AD vector. Okay, so just generate the 4 vectors which you want. Now the next step is that you must be familiar with the theory of parallelogram. What I mean by parallelogram are the figures they have like squares, rectangles, rhombus, etc. which have the opposite sides as parallel. So we have generated the 4 vectors here. Now the next step is that find the midpoint of A and point C. So if we have the midpoint of point A and C, so we have the midpoint as OA vector plus OC vector upon 2. The midpoint of A and C will be OA vector plus OC vector upon 2. And the midpoint of B and D will be equal to what? OB vector plus OD vector by 2. This is basic coordinate geometry that the midpoint has to be the half of this. So what I want you people to do is that if this is one equation and this is the second equation and both of these are equal, like for example this is 3i cap and this is also 3i cap and this holds true, then we can move on further to decide that which type of quadrilateral this is. So if we have the value of the equation 1 equal to equation 2, then the following 4 cases are possible. So now let me take the vector AB and the vector BC. So if we have a rectangle, then AB and BC will be perpendicular to each other. So what does it imply? That AB dot BC has to be equal to what? If they're perpendicular, the dot product is 0 because cos 90 is 0. Now moving on to the magnitude of the vectors. If this is a rectangle, then what we'll have? The magnitude of this vector, that is the 2 adjacent vectors, won't be equal in nature. So I want you people to know that we should solve these type of question vectorially because many times the problems are in the vector form. Now moving on to the square, we have AB dot BC to be equal to 0. Why? Because these are perpendicular and hence the perpendicular will have the cos theta as 0. Now the magnitude of the adjacent ones will be equal because this is a square. So AB vector magnitude will be equal to BC vector magnitude. Now moving on to the rhombus, we all know that the rhombus is something like this. in which all the sides are equal in nature but the right angle is not present. So AB dot BC won't be equal to 0, but the magnitude of AB vector will be equal to magnitude of BC vector. Now moving on for the parallelogram, again AB dot BC won't be equal to 0 because the sides are not perpendicular to each other, and moreover the magnitude of the adjacent sides won't also be equal. So we can see that we can decide the nature of these figures on the basis of vectors also whenever this condition holds true. Now what happens if this condition not holds true, seeing on the next page. So if that condition doesn't hold true, implies that the midpoints of these two sides won't coincide, then we have two cases possible. The first one is a trapezium. So what happens in a trapezium? That the two opposite sides will be parallel to each other. So what we can say that two sides are parallel. Now how we used to decide that? We used to take A bar is equal to lambda C bar from the basic vector theory. But what happens if it is not a trapezium also? Then the last case is it is a general quadrilateral. So what we have to do? We have to now approach normally. So we have to approach these type of questions in a normal manner, and because it is none of the above counterparts. Now moving on to the next part, which is regarding direction cosines. It is the angle made by the vector along with the x, y and z axis respectively. So let us see that how to solve this. So let me take first of all any vector, that is ai bar plus bj bar plus ck bar, where I bar is the vector along the unit vector along the x direction, j bar is the unit vector along the y direction, whereas k bar is the unit vector along the z direction. So we have taken any vector here. Now for finding the angle with the x axis, let us take any vector, that is k I bar along the x axis. So we have taken the vector along the x axis and we have taken our normal vector, that which we wanted to find the angle with. So we know that a bar dot b bar is equal to mod a bar into mod b bar into cos theta. Now we are finding the angle with the x axis first of all. So what is a bar here? Let me take this one. So ai bar plus bj bar plus ck bar dot, now we are finding the angle with the x axis, which is ki bar. So ki bar is equal to mod a. Now what is the modulus of this thing? See, a was this vector, so we need to find the modulus of this thing, which is equal to under root a square plus b square plus c square. Now what is the modulus of b vector? The modulus of b vector will be only equal to k into 1, because the modulus of I is 1. So the modulus of k is mod k into cos theta. So I'm taking theta to be alpha, where alpha is the angle made by the vector with the x axis. So okay, because it is a conventional term, so I'm taking alpha only. So we have generated this statement. Now solving it further, so ai bar dot a dot ki bar will be equal to a k, and bj bar will all vanish because we don't have j terms there, is equal to under root a square plus b square plus c square into mod k into cos alpha. So k and k gets cancelled. So cos alpha will be equal to a by under root a square plus b square plus c square. So we have generated the cos alpha. Now finding the cos beta. So let us take any unit vector, any vector along the y-axis, necessarily not the unit vector. So we are taking k j bar. Okay. So now again using a dot b is equal to mod a mod b cos theta. Now a vector is equal to ai bar plus bj bar plus ck bar dot b vector will be equal to what? It is kj bar dot kj bar is equal to mod a. What is the modulus of a? That is under root a square plus b square plus c square. What is the modulus of b from here? That is k into cos beta. Now we are taking alpha for the x-axis, and now we will be taking beta for the y-axis. Now multiplying these two, the dot product ai bar and ck bar will vanish because we don't have any I and k here, and b dot bj bar dot kj bar will be equal to bk, which will be equal to on the right hand side as a square plus b square plus c square into k into cos beta. K and k gets cancelled, so cos beta will be equal to b by under root a square plus b square plus c square. So we have derived the cos alpha, where alpha is the angle made by the vector with the x-axis, where now cos beta has also been derived, where beta is the angle made by the vector with the y-axis. And now similarly we can derive cos gamma also, which you can just notice by the pattern that is followed, which will be equal to c by under root a square plus b square plus c square. So we have derived the cos alpha, cos beta, cos gamma. So these three are known as the direction cosines for a particular vector. So these cos alpha, comma cos beta, comma cos gamma have been derived, which are known as direction cosines for the vector. So I hope you have understood the process, that how we are deriving. We just need to find the angle with the x, y and z axis. Now the last part is we are taking this to be equation 1, this to be equation 2 and this to be equation 3. So cos square alpha will be equal to a square by a square plus b square plus c square, just squaring this one. Cos square beta will be equal to b square by a square plus b square plus c square. Cos square gamma will be equal to, from here, c square by a square plus b square plus c square. Now adding this three terms, that is cos square alpha plus cos square beta plus cos square gamma. So let us see that what is derived. So cos square alpha plus cos square beta plus cos square gamma will be equal to a square plus b square plus c square upon a square plus b square plus c square. So these both cancel, giving me 1. So what we have derived, and what I want you people to remember, is that the sum of the squares of the direction cosines will always be equal to 1. So this result I will be using in the next video also, so you must remember it. Now the question which comes is that, let me discuss. Find sin square alpha plus sin square beta plus sin square gamma. So how we can solve it? A very easy question. This is the first video, so I'm just taking the easier parts here. So cos square alpha will be equal to 1 minus sin square alpha. Similarly, cos square beta will be equal to 1 minus sin square beta, and cos square gamma will be equal to 1 minus sin square gamma, which will be equal to 1. Taking sin square alpha, sin square beta and this on the other side, so I'll be getting sin square alpha plus sin square beta plus sin square gamma is equal to 1 plus 1 plus 1, 3 minus 1, that is 2. So the value of this one is 2. So I hope that you have learned how to derive the direction cosines in this video. So in the next video we shall be moving on to the higher level questions. Best of luck to everyone.